The diagram shows a cylindrical storage container of radius 1.5 meters and height 4.2 meters. So here we have this diagram. It says using pi as 22/7, calculate the volume of the container when full. Now the volume of the cylinder, the formula is cross-sectional area multiplied by height or length. And so the first thing that we're going to do is we're going to figure what is the area rather of the cross section. And this will help us to figure what is the volume. Now, what is the cross section of the shape? Well, the cross section of the shape is a circle. And so we have to figure out the area of this circle. Now, the formula for the area of the circle is pi r squared. Notice that pi is 22/7, but what is r? Well, r is the radius, and the radius in this case is 1.5. And so we substitute those values in. We have pi is 22/7. We have r, which is the radius, is 1.5. And so we have to do the computations. What is 1.5 squared? Well, 1.5 squared is going to be 2.25. And we put it over 1 because we have to multiply by this fraction. And we say 22 multiplied by 2.25. And 22 multiplied by 2.25 is going to be equal to 49.5. And we have 7 multiplied by 1. And 7 multiplied by 1 is definitely 7. Next, we divide these two. And when we divide them, we get 7.071428571 meters squared. And that's the area of the cross section. But remember, the volume is equal to cross-sectional area times height or length. So what we have to do is we have to take our cross-sectional area, which is this, and we have to multiply it by the height. In this case, it is 4.2 meters. And so when we multiply them, when we multiply these two quantities or these two numbers, what do we get? We get 29.7 meters cubed. And that's the volume of this container. And that's the volume of this container. Next, we have to continue with this next question. It says that the contents of the container are packaged in boxes with a square base of side 15 centimeters and height 20 centimeters. Calculate the volume of a box, given your answers in cubic meters. So the first thing we have to do is we have to take, notice that we have 15 centimeters and we have 20 centimeters. We have to figure out the volume of the box in cubic meters. Meters is not the same thing as centimeters. So we have to take centimeters and convert it into meters. So how many centimeters? So I'm sorry. So what we have to do is we have to take 15 centimeters and convert it into meters. And we have to take 20 centimeters and convert it into meters as well. And so what is this, right? So in order to convert 15 centimeters to meters, we have to divide by 100. So 15 divided by 100 is 0.15. And so that means that 15 centimeters is actually 0.15 meters. And then we have 20 centimeters. And in order to convert that into meters, we have to divide by 100 again. So we have 20 divided by 100, which is 0.2. And so we have 0.2 meters. Next, we have to figure out the volume of the box. Now, the volume of the box is going to be equal to the cross-sectional area multiplied by the height, which is 0.2 or 20 centimeters. Now, what is the area of the cross-section? Well, the cross-section is a square, right? And so that's length times width. And length times width is definitely, in this case, 0.5 meters times 0.15 meters times 0.15 meters, because in a square, the length and the width are the same. So if one side is 0.15 meters, the next side must also be 0.15 meters. So the area of the cross section is going to be 0.15 meters multiplied by 0.15 meters, and we multiply that by the height. All right, and so when we multiply them together, we get when we multiply 0.15 meters times 0.15 meters, we get 0.0225 meters squared. And when we multiply that by 0.2 meters, we get 0.0045 meters cubed. And that is the volume of the box given in cubic meters. Next, it says calculate the number of boxes that can be packaged from a full container. So in order to do this, we have to divide. We're just going to take we're just going to take 29.7 meters cubed. That is the volume that we got originally from the volume of that cylinder. And we divide it by the volume that we just figured out in part B, which is 0.0045 meters cubed. And so when we divide these two, we get 6,600 boxes. So the number of boxes that can be packaged from a full container is 6,600 boxes. And that's the answer to this question.